So what can we do with vectors then? Are you happy that we can add and subtract vectors? Are you happy what the geometric meaning of adding vectors and subtracting vectors is? So just remind me, if this is A, what would negative A be? So what's the geometric application of negative A? So if A is a movement from here to here, what would negative A be? It's the opposite direction, right? So instead of going from P to Q, negative A would be going in the exact opposite direction. So it could be going from Q to P. Okay? So that's a negative of A.
But it will be minus 3, 4,
yeah, exactly. It'd be negative 3, 4 because you'll be going now 3 to the left and 4 down. Okay, instead of going 3 to the right and 4 up. Okay. Now here's my question to you. Here's my question. Let's still stick with A. Let's still stick with A as 3, 4. But here's my question. What would this be geometrically? What would 2A be geometrically? So don't tell me what the answer is in terms of column notation. Tell me what it means to do 2 lots of A geometrically.
Longer.
Good. So instead of just going along A once, so here is going along A once. Let's do this. So A is going from here to here, okay? But I don't want to just go along 1A. I want to go along 2 lots of A. So I want to go along A. So I move from here to here. Then I move from here to here. So in other words, I go along A again. So in total, what I have done is I have moved from here right the way out to here. That's 2A. That's 2A, okay? Because I've just moved along A twice. What would 3A be? Yeah, I'm moving along A 3 times, okay? Now, what's the relationship between 2A and A? What's the relationship between this and this? They're parallel to each other. Good, yeah, because they have to be. Like, I've literally gone along A, then I've gone along A again. That has to be in the same direction as A, yeah? So what we can say then is that if you have 2 vectors which are scalar multiples of each other, in other words, if that's A and that's 2A, A has just been multiplied by 2, they are scalar multiples. Remember, scalar is just simply a number. So if 2 vectors are scalar multiples of each other, what that literally means is that they must be parallel. Good. Okay. So in fact, 2A would be, can you tell me now in terms of column notation what 2A would be? Yeah, you just times each of these components by 2. So 6 and 8. Okay, so you see here that these 2 vectors are parallel because they are scalar multiples of each other. So let me give you another example. What about this? Let's suppose that U is equal to 7, 4, 2. And let's suppose that V is equal to negative 7. Wait, no, negative 14, let's go. So negative 14, negative 8, and negative 4. Would these 2 vectors be parallel to each other? So 7, 4, 2 is U, and V is negative 14, negative 8, negative 4. Are these 2 vectors parallel to each other?
Yes, they're parallel, but they have a different destination.
Okay, so yeah, it has a different destination, but then this has a different destination as well. I don't care about the start and end points anymore, I care about the movement that's happening between them. Are they parallel?
Yeah, but if you will continue, it will be parallel.
Yeah, good. So they have different lengths. They have different lengths. Are we happy? They're traveling in opposite directions, but are they parallel? Yes, absolutely. Because if I drew this, 7, 4, 2, it would be kind of like, okay, 7 across, 4 up, and 2 out the board. So it would be like from here to here, okay? And if I did this, it would be traveling in the opposite direction, but it would still be parallel to each other. They'd still be parallel to each other. Does that make sense? Because what's the relationship between U and V? What have I done to U to get V? Good. I've just multiplied by negative 2. Okay, so V must be equal to negative 2 lots of U. Therefore, they must be parallel. Because negative 2 is just a scalar multiple. It's just a number. Is that okay? Yeah?